Okay, good evening. You're welcome to physics class. I could remember that last class we discussed motion and some equation on motion. And so we'll just quickly continue in that line, possibly trying to fix one or two questions uh, as much as possible. Um, I gave an assignment last class. I don't know if anybody was able to attempt that. Hope there is no problem solving that question, so I can just quickly move on. Okay, now I have a lot of questions here that I would have loved that we solve. So it will mean that as you listen to this, you need to take notes of a lot of things because the questions are long, so I might not want to write them. I can just dictate them and then I will do the solution on the screen. So, and I move on like this. A train has an initial velocity of 44 meters per second. I come again. A train has an initial velocity of 44 meters per second and an acceleration of minus 4 meters per second square. Acceleration of minus 4 meters per second square. Its velocity after 10 seconds is dash. Its velocity after 10 seconds is dash. This is a jam question. If you 1983 past question, you will see this question in one of the questions there. 1983 past question. Okay, so I want to the solution. I want to put up the solution now. Okay. All right. So we were told that a train has an initial velocity. So you need to state your parameters. What are the parameters? Your velocity is 44 meters per second. 44 meters per second. Okay. 44 meters per second. Don't forget that you have to write in standard units. Acceleration of 4 meters per second square, that is A is equal to minus 4 meters per second square. Now, when your acceleration is minus 4 meters per second square, what does that mean? What it means is that the car is actually decelerating. Deceleration is negative acceleration. So when the car is accelerating, that means the rate of change of velocity with time is increasing. All right. The velocity is increasing as the time is increasing. All right. So the car will speed up. That's what it means. But when a car is decelerating, it's slowing down. Yeah, that is why acceleration will now become minus. All right. So please note that. Now, they are now saying that we should find the velocity of such a train after 10 seconds. So what do we need to do? We are looking for the velocity. V, we don't know, but T, we know is 10 seconds. So what we need to do is, what do you think, out of the equations we gave out last week, which of them do you think will be suitable for us to combine in order that this one can give us something nice? Of course, you remember that from the equation that says V is equal to U plus AT, V is equal to U plus AT. That's what we are going to use. V is equal to U plus AT. Where V is the final velocity we are looking for. Initial velocity has been given as 44 plus the A is minus 4. Then the T is 10. So at the end of the day, what we are going to have is 44 plus minus 40. And that is equal to 44 minus 40 because plus times minus is minus. So the answer is 4 meters per second. That's the answer, 4 meters per second. The answer will be 4 meters per second. So I can pick as many JAMB questions as possible. Let me pick this one. This one is another nice one. I think today we will just try and explore questions, making use of all the information we have already since last week. I want you to write, okay, let me be dictating another question while I retain the previous solution so that you can be copying. This is another question here. A body starts from rest and moves with uniform acceleration of 6 meters per second square. I come again. A body starts from rest and moves with a uniform acceleration of 6 meters per second square. What distance does it cover in third second? I need you to pay attention to this. What distance does this cover in third second? So we are talking about when the body starts from rest and move with uniform acceleration of 6 meters per second square. So for the third seconds, we need to know the distance it covers. Okay, in order for us to solve that, now we need to state our parameters. Let me come again with the question. A body starts from rest and moves with uniform acceleration of 6 meters per second square. What distance does it cover in the third second? Good. So for the body to start from rest, initial velocity is 0. All right, u is equal to 0. Let's keep that. Then now it now moves with uniform acceleration, a to be equal to 6 meters per second square. All right. Now, what distance does it cover in the third second? T, you have to be careful. T is equal to 3 does not mean it is total time of 3. All right, so here, what we are going to do is simple. At t is equal to 3, I need you to pay attention to that. So what formula do you think we can use here? What formula do you think we can use here? You remember that we can use for each of the seconds. I want you to pay attention to this. V is equal to U plus AT. All right? Pay attention to that. Now, when it is the first seconds, I need you to pay attention to that. It will be V is equal to 0 plus 6 times 1 at t is equal to 1. Velocity at first seconds will just be 6. Pay attention to that. All right, so I call it T1. When it is T2, velocity at second seconds, that is when it is now 2 seconds, the initial velocity will still be 0, then AT2, that is when the time is 2 seconds. So you are going to have 0 plus 6 times 2. So you have 12 meters per second. Now, you know that, of course, what you are going to note is that the rate of change of velocity with time is constant because they said the acceleration is uniform acceleration. Can you now see that if I decide to take the speed at the first second from the speed at the second second, I will still get 6. So if I want to get it at the third seconds too, I will still get 6. That's where I'm going. Now that we know that, we are interested on the distance it covers. The distance it covers. Say, what distance does it cover in the third second? So let us now go. You know that we have S is equal to UT plus half AT square. UT plus half AT square. The reason why we are using this now in the third second, this is where I'm going now. In the third velocity that it will get will not be 0 because velocity at the end end of seconds, we know is what? Is 12. The velocity has increased. When it is the total time, velocity at the end of second is 12. So we'll use the velocity at the beginning of third seconds, which is 12 at the end of second, to calculate the time for third second. Third seconds is just 1 second. Let me break it down in this way so that we will now know what to do. This is the entire line. The first second, the second one. So in terms of seconds now, first second, second, and then the third second. So we want to know the total distance to cover for the total journey it traveled in the third seconds, not the entire 3 seconds. So we have to be very careful with that. This JAMB question, you will see it. Let me quickly look for the year. This is 1992 JAMB. If you are interested in looking for that particular question, you will see it in 1992 JAMB. Okay, so you can see the technicality that this question carries with it. Okay, so at the end of the day, don't forget the 3 seconds have been broken into 1 seconds each. We only need the speed at the end of the speed, the third second, the speed at the second is the one that will start as the initial velocity for the third second. So keep that as 12. And then, of course, we will now use S is equal to UT plus RVT squared. So in this case now, we are going to now say our S, which we don't know, is equal to 12 times 1. The 1 is the third seconds, not 3 seconds. The third seconds plus half. Our acceleration is 6. All right. And then, of course, 1 square. UT plus half 80 squared. So that will be 12 plus 2 here, 1. 2 here is 3. 3 times 1. 1 raised to power 2 is still 1. So 12 plus 3. And then the answer will be 15 meters. 15 meters. And 15 meters is the correct answer you will get if you follow the way I've solved it. Option A in my own, on my own end here. Option A on my own end here. Okay, I want to repeat the question again so that we know why we are solving what we solved. A body starts from rest and moves with uniform acceleration of 6 meters per second square. Full stop. What distance does it cover in the third seconds? Okay, so that's what we have there. That's what we have there. And that's the answer. The answer is 15 meters. So let me quickly reverse back to the previous slide and what we have so that you can see how we started the solution to that one. Since a body is starting from rest, initial velocity is 0. Since it is with uniform acceleration of 6 meters per second, we have that. We calculate the velocity for the first second. We calculate the velocity at the end of second. So the velocity at the end of second is what we are going to use as the initial velocity for the beginning of the journey of the third second. So now that 12 will now be our initial velocity. It will now replace U. T is 1 because it's the third seconds. We are not talking about the entire time. We are talking about the third second of that journey. So it will just be 1 second. Our A will remain because it is uniform. Uniform acceleration means for each change in time, acceleration is uniform, is the same. The word uniform means is the same. I explained that last class. Okay, so we can keep that. And then, of course, using the equation, you are able to get what we got here as our answer. S is measured in meters, so that's distance. So it's 15 meters altogether. Okay, I feel like I should solve one more question and then I'll move on. Let me see. Can pick any nice jump question here. I want to look for one, possibly the one that is recent. Okay. One of the challenges is you have to keep looking for questions across. Okay. Think. Okay, I like this. I think I should like this. JAM 2009. Very nice question. So it will take us, because I explained some concepts around vertical velocity last time. Treat the okay, sorry, I think my network went a bit off. So okay, so I want to quickly address JAM 2009. So let me just quickly state the question. A bullet fired vertically upward from a gun held 2 meters above the ground. Let me come again. A bullet fired vertically upward from a gun held 2 meters above the ground reaches its maximum height in 4 seconds. Reaches its maximum height in 4 seconds. The now question is calculate the initial velocity. Calculate the initial velocity. Okay. Now, when you want to solve this question, you need to understand I gave you all the formula last week that, thank God, is even going to be an extension of what we just solved now. From the equation of motion that says S is equal to UT plus half AT squared, I said that if it is going to be vertical velocity, I told you that distance will turn to height. Now, because initial velocity has to be given, no object on its own can move up except one has given it a particular energy to jump up. That means you are supplying the initial velocity. So initial velocity will be given, the time will be stated, but because it is going against gravity, it will not be a positive, it will be negative. So you have half, then your A will turn to acceleration due to gravity. You have this. Okay, so this is all you have. All right, and then you don't forget also that we were given the formula, we were given the value. So let us state our parameters. They said that it reaches its height in 4 seconds. We don't know the h, we don't know the initial velocity. No, it's not u. We don't know h, comma, we don't know u, comma. This is what I wanted to write. We know t is equal to 4. Our g, of course, will be given as 10 meters per second square. Is a constant. Is a constant. So in this particular formula now, we will not be able to use it. Why? Because there are two parameters that are here that we don't know. Is there any other parameter? Is there any other formula that we know that we can use? Or can we think of any other formula that we can use? Yes, you remember that we have b square is equal to u square plus 2as, which you can turn to. Don't forget that I said that at the maximum height, when an object is going up, final velocity will be equal to 0. So this will be 0. Initial velocity will be given. It is going against gravity, so there will be minus 2gh. And at the end of the day, you can equate it to now say u. Okay, I can write this on the next slide so that it will not disturb this thing here. I want to write my 0 very well here. At the maximum height, final velocity is equal to 0. So we have this. So what we are going to do is simple. What we are going to do is very simple. We are just going to say, since this is equal to 0 is equal to u minus 2gh, means I U is equal to 2GH. That's what I want to go and write next now. U is equal to 2GH. So I'm going to write that my U is equal to 2GH. All right. I don't know my initial velocity. And that is what they want me to calculate here. They want me to calculate my initial velocity. So, but I know that acceleration due to gravity is what? Acceleration due to gravity is what? Is 10. So I can decide to say U is equal to 2 times 10 times h. So here my initial velocity will be equal to 20h. That's what I will have here. My initial velocity is equal to 20h. Okay, 2 times 10 times h. Now, I will now go back to the previous one where I have that h is equal to ut minus 2g minus half at square, sorry, minus half gt square. Half gt square is not 2gt, it's minus half gt square. Now, I know that my u is equal to 20h, all right? And they say that this thing got to its maximum height in 4 seconds. I'm looking for u. So if I decide to make h the subject of the formula here, to eliminate h, that's what I wanted to do. It's the same h that you have here that you have here. The two h are the same. The h here is the same thing as the h here. All right. So in this case now, I can do something. I'm looking for u, so I can make h the subject of the formula from here. If I make my h the subject of the formula, my h will now be equal to u over 20. All right. So I can, anywhere I see h, I can put this. So therefore, I will use this one to say u over 20 is equal to u into bracket 4. We're given the time to reach its maximum height as 4, minus 1 over 2 into bracket 10, then 4 square. Let me just rewrite. I think I should rewrite. Well, it's the same thing I want to rewrite. U over 20 is equal to U into bracket 4 minus 1 over 2, then into bracket 10, then 4 square. Because my t is equal to 4. So this one will now, by the time you substitute all of this, you will get the value of your u, because they say find the initial velocity. So it's about substitution. If you are very good in mathematics, you won't have problem with physics. So this one will now be u over 20 to be equal to 4u minus 2 here 1, 2 here is 5. Then 4 square is 16. 16 times 5 is 80. Yeah, 16 times 5 is 80. So I can just do all of this over 1 so that I can cross multiply. So what you are going to have is u is equal to, this one will multiply, that will be 80u minus 80 times 20 is 1,600, I want to believe. Yes, 1,600, I'm right. 20 times that, 20 times that, yes, ut minus half gt squared. Yeah, it balances. So you now collect like terms. I can bring this one out. So I have 1,600 is equal to 80u minus u. And that is 1,600 is equal to 79u. So when you divide that, is somebody going to divide for me, or I should just quickly use my on-screen calculator to do that? Let me use on-screen calculator to quickly do that. Definitely, you know you'll be given calculator. So there's nothing to worry about. 1,600 divided by 79 is an approximate value, 20.25. Okay, so you are going to have you are going to have 20.25 if you do that. So 1,600 1600 is equal to 79U. So if you divide both sides by 79, divide by 79, this one will cancel this. So your U initial rate is equal to 20.25. 20.25 initial velocity, meter per seconds anyway, 20.25 meter per seconds. Or if they ask you to calculate it to the nearest whole number, you have 20 meter per seconds. And if it is to one decimal place, 20.3 meter per seconds. But in this case, I think they approximated to the nearest whole number, which is 20 meter per seconds. Option D, all right, to the nearest whole number here, option D. That's what they did. So you can try it on your own again. A bullet fired vertically upward from a gun 2.0 meter above the ground reaches its maximum height in 4 seconds. Calculate its initial velocity. So initial velocity we found out is 20 meter per second. Okay, so that's all that I think I should. You can solve as many questions on it. I want to talk about another concept. I don't know, maybe let me talk about another concept now. Let's talk about moment or momentum. No, before we go to moment, let's discuss momentum. Momentum is product of mass and velocity. And I think you will just explain or establish the concept now. Probably next class also, we can also discuss some questions to be solved on momentum. So I want to talk about momentum. Momentum. Like I said, when an object is moving, there are two things that are responsible for the movement of an object. Number one thing that is responsible is mass, the mass of the object itself. And the number two thing that is responsible is the force that is pulling the object. So I talked about the mass and the force, the mass and the force. All right. So there is something called inertia. You define inertia as the reluctance of an object to start moving. And once the object starts moving, it is still the reluctance of that same object to stop moving once it starts moving in a straight line. That's what we call inertia. That is why it will be easier for you when a bicycle is parked. It is easier for you to go to the bicycle and push the bicycle. Why? Because the bicycle is not heavy. But when a trailer is parked, it is not easy for you to go to where a trailer is parked and push it because the mass. All right. And when a bicycle is rolling, it's easier for you, or when a bicycle is moving at a very high speed, it will be easier for you to go and stop the bicycle. You can quickly pull it and it will stop. But when a trailer is moving, it's not easy for you to go and stop a trailer. Why? Because of the mass. So the mass of an object plays a very important role in its motion. All right. And that is what we want to talk about in momentum. All right. Momentum is product of mass and velocity. Product of mass and velocity. And when we find the rate at which a mass is also moving with its velocity, then we are now already discussing the force that is responsible. But for now, I'm going to stop on the momentum. Next class, we are going to discuss the issue of the mass of the object. Okay, I mean the force that is responsible for the object. Let's see if we can push it that far tonight. So I say momentum is equal to mv, where m is mass and then v is velocity. All right. Don't forget that mass is measured in kilogram, velocity is measured in meter per second. So the unit of momentum is kilogram meter per seconds. Kilogram meter per seconds. Yeah, I'm right. Kilogram meter per seconds. Or what you call Newton, as the case may be. We'll get there. You can call it Newton seconds. So the unit is kilogram meter per seconds or Newton seconds. That's the unit of measurement of momentum. That's the unit of measurement of momentum. All right. Now, why are we going to be talking or discussing momentum? We are going to be discussing momentum based on the theory of collision of objects. We are going to be talking about collision of objects. When objects collide, what are the observable things that we can note? When two objects collide, when two objects collide, two objects that are moving on a straight line, when they collide. So I can have something like this. I would say I have M1, I have M2, M2. There are two or several ways that we're going to consider. If one is coming this way and the other is coming this way and they collide, two things are likely to happen. Before collision, so I will write B4 for before, then I will write AF for after. Now, when the two objects, one is moving in this way, the other one is moving in this way, so the two objects are moving in opposite direction. The two objects are moving in opposite direction. After collision, what are the things that can happen? The two things that can, or several things that can happen is that once they collide, M1, the first mass, bounce back, and M2 also bounce back once they collide. Another thing that can happen is that, let me write or there, is that M1, after colliding with M2, pushes M2 in the direction in which M1 has been traveling. Another thing that can happen, several things can happen, depends on the mass and depends on the speed. So I'm just giving you every possibility of something that you can experience. So it depends on the mass and speed. So that's when you will know where what is happening. But these ones are basically on linear motion, because we can have a situation where one can bounce at another angle. We are not going to consider angular momentum now. We want to consider linear momentum. All right. So I can have a situation where M1 itself, and after M2 1, this is 2, bounce this way. All right. That is, they move back. This other one obey the direction of movement of the other one. All right. So definitely, in a way, it is a phenomenon that both of them will just stop moving. It's not really a common phenomenon that the two of them will just stop moving and then they will remain at a point because of impulse. Impulse we have first condition, the second condition, or the third condition. So let's consider the first condition. Consider the first condition first. Now, considering the first condition, the momentum we call momentum before after collision is preserved. Two things that will happen is that, look at me, I'm going to have time, you understand that M1, two of them will move with different velocity. M1 will move with a final velocity, another velocity, because in each change, to another velocity, which velocity of this mass. So you have this for objects that once they collide, they move with different velocity. Vector is very important. So when an object is moving in an opposite direction, we must be talking about solving questions on them. I think we have about 7 minutes left. I want to believe we should have all seven. The stars move in the direction of the first one or the second one. Scenario. Then two, and that will be plus M2. Now, for this one, what it means is that both of them move with the same velocity. So we now cannot say whether they are moving in the direction of M1 or they are moving in the direction of M2. But please note, I want to bring up the scenario again that we explained. These are the scenario. It's either that when both objects are moving before collision, M1 and M2, then after collision, we are observing three things. The first one is that, in fact, I can tell you that the second equation observes both of these. Yes, it observes both. So the second equation is valid for these two conditions. So it's either that after collision, both masses move with new velocities, new final velocities in different direction or whatever. They just move with different velocities. Or they move with the same velocity because they are like they stick together now, because one will be pushing the other to be able to obey the direction of movement. That is the truth. When two cars hit themselves, you will see that one will push the other away, depending on the mass of the heavier car. If a trailer should hit a bicycle, you don't expect the bicycle to push the trailer backward. It is the trailer that will push the bicycle. So that is exactly the interpretation that we have here. So, like I said, this is the first scenario after collision, while this represent the second scenario after collision. So it's either that they move in direction of M2 or they move in the direction of M1. But what we know is that they are going to move together. All right. So please note that. So the equation that I'm writing, that I've written already, addresses what I just put up. So this is the equation for the first scenario. This is the equation for the second